Like many things in math, like and unlike terms are something that seems very straightforward and obvious once you get it. But you have to understand a few subtleties in order to get it in the first place. So we're going to start here by just pointing out that when you have a positive and a negative, you always cancel each other out. So 3 plus negative 3 just gives you 0. Similarly, negative 5 plus 5 gives you 0. 2x and negative 2x give you 0. Negative 7x and 7x give you 0. And similarly, 4x squared and minus 4x squared give you 0. Now, what I haven't really said, but what all of these show is that when I'm talking about a positive and negative, I'm really talking about the coefficients. And what we're going to see in this section is that you can only combine objects if they are like objects. So notice that I didn't have 2x combined with just a minus 2. It had to be combined with a minus 2x. And I had a 4x squared combined with a minus 4x squared, not a minus 4x or a minus 4. So as long as the kind of variable part is the same, then all I'm really doing is combining the coefficients. It's a little bit like counting objects, and that's going to become more obvious when we look at a picture, when we look at some algebra tiles. So to be very specific, like terms must have the same variables, and the variables must have the same exponents. So let's take a look at, I've got 2 rows of examples here. Oops. So in that first row, those are all like terms. The first one, x squared y cubed, is a like term, or considered a like term, to 3x squared and y cubed, and to 17x squared and y cubed, and to minus 4x squared and y cubed. So we're not concerned with the coefficient being different. We're concerned with the variables being exactly the same and the exponents on those variables being exactly the same. Similarly, the second row, xyz, is a like term with minus 2xyz, with 10xyz, with minus 7xyz. And don't get confused or tricked if you see some polynomials where the variables are written in a different order. Remember, they're just products, and you can put the products in any order you like. So if you saw an xyz with an xzy, those are the same 3 variables, same exponents, and so those are like terms. Now, how do we do this with something a little bigger? So I've got a picture here, and using one of the tools I showed you in the last lesson. So let's think about this as 4 separate terms. I've got a 2x squared. I've got a 3x. I have a minus x squared. And I have a 2x. One way of thinking of like terms is we're really just grouping or dealing with things that are of the same shape. So I have the 2x squared here. That's the same shape as this one right here. Now, one's positive, one's negative. In one case I've got 2, in the other case I've got 1, but in every case we're just dealing with those big square tiles. So those I can combine. And if I'm combining 2 big tiles with 1 negative tile, remember the positive and the negative are going to cancel each other out. Well, I can only cancel out 1 of those tiles. So for instance, if I were to go into this tool, I could say, well, that one and that one kind of cancel each other out. And in some of the tools, you have a way of kind of getting rid of them. But we'll, for now, just say that those 2 cancel each other out. And what does that mean? What are we left with? We're left with that single x squared term. We could have gotten the same result by saying, well, if I have 2 of something and I take away 1 of them, I have 1 of them. So what am I left with? I'm just left with x squared. And then similarly, I've got these 3x here, or 3 rectangles, and I've got 2x, or 2 of those rectangles. So those I can combine. That gives me 1, 2, 3, 4, 5. And so I end up with 5x. And all of these are, part of a bigger polynomial, perhaps, and we can just think of them as having plus signs in between them. All right. Now, when you're adding a negative, sometimes you would just write that as minus x squared, or you could put the negative x squared in brackets. But one thing that's important to realize is polynomials are a sum, right? All of those terms are being added to one another. The coefficients might be negative, and sometimes that'll be written as just minus x squared. But keep in mind that it really means plus negative x squared. So give the problems in the textbook a try, now that you understand what constitutes a like term. And I think you'll find this once you get it, it's just very straightforward.